So in this video, I'd like to go over how to solve equations. In order to solve equations, we need to be able to use inverse operations to isolate a variable. So I'm going to go in and tell you what that means. Let's say that we have x plus 5 equals 9. So in order to solve for x, to figure out what the variable's quantity is to make this a true statement, we need to get x by itself. In order to get x by itself, we do something called isolating x. Just like if you were completely alone, you would be isolated. We want x to be completely alone or be isolated. So that means we need to take everything that's away near it and discard of it. The thing in an equation is it needs to remain balanced the whole time. Okay, so if you do one thing to one side, you have to do the exact same thing to another side. It's like if you had a scale, all right? And let's say you had 5 pounds over here, and let's say you had 5 pounds over here. And this equal sign is in the middle. It's the fulcrum that's in the center, okay? Keeping it balanced. If I take away 2 pounds on this side, I would get 3 pounds on this side. But then this side would be way too heavy. So I need to take 2 pounds, not just from this side, but this side also. And if I take away 2 pounds from this side, I even the equation back out again, so it's back and even. Okay? So even though I had 5 equals 5 before, 3 equals 3 is just as true a statement as that as well. Okay, so whatever we do to one side, we do to the other. It's called the property of equality. This is called the property of equality. Property of equality says whatever you do to one side, you have to do to the other side. Okay, so if I take away 2 from this side, I need to take away from 2 this side. If I add 8 to this side, if I add 8 pounds to this side, 8 and 3 is 11. So then this side would go, whew. So I need to add 8 pounds to this side as well. So if I add 8 to this side, I have to add 8 to this side so it balances back out. Again, property of equality, okay? Likewise, if I had, let's say 10 pounds over here and 10 pounds over here, and I divided this side by 2, I would need to divide this side by 2 as well. If this 10 is divided by 2, it becomes 5. So I need to do the exact same thing over here to keep it. As well as multiplying. If I were to multiply this side by 3, I would have to multiply this side by 3 as well. So this is what the property of equality means. Whatever you do to one side, you have to do to the other. Okay. So how do we get x isolated here? Well, I don't want this positive 5 here. So what I'll do is I'll take away the 5. So now I get x by itself, because this is just 0 now. So it's like x plus 0. But since it's plus 0, you really don't need that 0 at all. But remember, whatever I do to one side, I have to do to the other. So if I took 5 away from this side, I need to take 5 away from this side. So that would be 4. And so 4 is indeed the solution for x. Okay? So if we had 2x equals 10, this is multiply, 2 times x. If you want to put a little multiplication symbol in here, go for it. So how do I get rid of the 2 here? So these are being multiplied against each other. So in the case before, we had something like x plus 5 equals 9. So here, these are being added. So I need to do the opposite to get rid of it. Well, the opposite is another way of saying inverse, okay? So when we do something that's opposite of something, we call it doing the inverse. And an operation, well, addition is an operation, subtraction is an operation, multiplication is an operation, and division are operations. These are all operations, okay? So that's why we call it the inverse operation. So the inverse operation of addition is subtraction, the opposite. The opposite or the inverse operation of multiplication is division, okay? So while we did subtraction when there was addition, here there's a multiplication, so we need to do the inverse of multiplication, which is division. So I'm just going to use it with a fraction line. I'm going to divide both sides by 2 with this fraction line. This fraction line means division. So do you see that now I have 2 over 2 times x equals 10 divided by 2 is 5. So any number over itself is equivalent to 1. Okay, so 2 over 2 is equal to 1. 10 over 10 is equal to 1. So 2 over 2 is equal to 1. So this is the same thing as 1 right here. Now 1 times x is the same thing as just x, because 1 times anything is this what that anything is. So now I get x equals 5. I have completely isolated. There's nothing next to it at all, this x. It is just by itself, so x equals 5. To prove that it's a solution, I could plug 5 back in for x and see if it turns out to be true, a true statement. So 2 times x equals 10. If I substituted 5 back in for x, it would be 2 times 5, and 2 times 5 indeed is 10. I get an identity. If I get an identity on both sides, that means it's equal on both sides, and that means it was a true solution. So now, let's put those together. Let's say that we have 2x plus 10 equals, I don't know, maybe how about say 20? Okay, so the first thing I do is if there's ever addition or subtraction, I'm going to take care of that first. I'm going to peel away the layers. So this 10 is a little bit further away from the x. It's not as closely tied as the 2, the coefficient of x. So let's get rid of these outer layers first. So I'm going to subtract 10 from both sides to get rid of 10, and then I need to do the same thing to the other side. So now I'm left with 2x on this side. 20 minus 10 is 10. Now, this is 2 times x. I'm going to do the inverse operation of multiplication, which is division, to both sides now. I'm left with x equals 10 over 2, or 5. So let's see if I plug 5 back in, if I get a correct balanced equation. So instead of saying 2 times x, it's going to be 2 times 5, which is what I claim the solution for x is in this particular problem. 2 times 5 is 10. I add it to another 10. And let's see if I get 20. 10 plus 10 is 20. Becomes an identity, and so x indeed really was 5. So I solved that equation. And when you solve it, you say x equals a number, and then you put a box or a circle around it. Okay, so I'll give you some problems to practice now. Thanks.